We continue learning workbook page 169 with our next problem. Given g of x equals numerator negative x plus 13 all divided by 7, and h is the set of ordered pairs defined as follows: 0, negative 1, 2, negative 3, 5, 0, 7, 6, 8, 7. Find g inverse of x, then totally new problem, find g inverse composed with g of 6, then totally new problem, find h inverse of 0. Okay, so we've got 3 problems in one here. Let's go ahead and start with the first one, and let's see if we can find g inverse of x. G of x is given to us as an equation. There are 4 steps for finding the inverse of a function defined by an equation. Let's go through them now. Step 1, turn f of x into y. Of course, in this particular problem, the name of the function is g of x, so we turn g of x into y. So we have y equals negative x plus 13 all divided by 7. Step 2, turn all x's into y's and all y's into x's. So we get x equals negative y plus 13 all divided by 7. Step 3, solve for y. Okay, well, once again we find ourselves with fractions, and once again we will clear those fractions by multiplying both sides of the equation by the least common denominator. Our only denominator is 7, so we're going to multiply both sides by 7. Now 7 is the same as 7 over 1, which means this 7 is in the numerator, this 7 is in the denominator, so those are going to cancel. So my next line of algebra will look like this. On the left, x times 7 will be written as 7x. On the right, these cancel. Anything times 1 is itself, anything divided by 1 is itself. So I simply have my numerator, negative y plus 13. Okay, now solve for y. I'm going to take this term and move it to the left, and this term and move it to the right. When a term changes sides, it changes signs. So I get positive y equals negative 7x plus 13. And I now have achieved the goal of solving for y. Step 4, turn y into f inverse. I get f inverse of x is equal to negative 7x plus 13. Of course, for this problem, the function's name was actually g, so we really should write turn y into g inverse, and g inverse of x equals negative 7x plus 13. All right, there we go. We have found the answer to the first part of this problem. All right, I'm going to set this up here in a box because it's going to be useful to us in a moment. We've now found g inverse of x, and that's equal to negative 7x plus 13. So let's put this in a box here. And now I will erase to make room for the next problem that we're going to solve. All right, the next one says to find g inverse composed with g of 6. All right, so g inverse composed with g of 6. All right, whenever you compose two functions, the first step is to rewrite using the definition. So we want g inverse of g of 6. Now it's been a long time since we've composed two functions together and had our input be a number. We have to remember what to do when that happens. When your input is a number, you work from the inside out, which means we're going to figure out what g of 6 is equal to first. So let's do that on our side workspace. We know that g of x is equal to negative x plus 13 all divided by 7. So if we want to know what g of 6 is, then we have to write that same line of algebra, but everywhere we see an x, we're going to put a 6 in parentheses. So a 6 here and a 6 here. And then we'll simplify. All right, so negative 6 plus 13 is 7, and 7 divided by 7 is 1. So g of 6 is equal to 1. So this thing right here that we were trying to figure out what is it equal to, that, which is the same as that, is just the number 1. So we're going to write a 1 here. And then everything else that was around it stays exactly the same. So g inverse of 1. Okay, so now we need to find g inverse of 1, and we're going to use the same process we did just a moment ago. It's the g inverse function this time, which is this person. We'll put this in our side work. G inverse of x is equal to negative 7x plus 13. But what we want to know is, what is g inverse of 1? Well, everywhere we see an x, we're going to put a 1 in parentheses. And then we will simplify. All right, negative 7 times 1 is still negative 7. Negative 7 plus 13 is 6. So g inverse of 1 equals 6. So our final answer for this part of the problem is 6. Now there's one thing I feel that I must share with you before we move on to the third part of this problem. What number did we start with as our original input? 6. What number did we end up as our final output? 6. Is this just a coincidence? No. Whenever you compose a function with its inverse, the starting input matches the final output. So a huge, huge time saver for solving a problem like this is to recognize that when a function and its inverse are composed together in either order, the original input is the final output answer to your question. Remember that. Okay, and that brings us to our final part of this rather long problem, which is to find h inverse of 0. All right, let's look at our function h. Our function h is composed of these ordered pairs, 0, negative 1, 2, negative 3, and so on and so on and so on. When an ordered pair is part of a function, then that tells me that the x-coordinate is the input and the y-coordinate is the output. So for example, this 5 is x. This 0 is y, also known as h of x. And so, using the ordered pair 5, 0, we can state the following is true. We know that y equals f of x. Of course, in this case, our function's name is h. So we'll write y equals h of x. This is an x, this is a y. Let's replace the numbers for the letters and see what it tells us. What it tells us is, in this particular instance, x is 5, so h of 5. Y is 0. Swapping the order, we get h of 5 equals 0. This is a very important skill to have when working with functions that happen to be sets of ordered pairs. The ordered pair 5, 0 would get written as the function statement h of 5 equals 0. Let's do that for just a few more of these, and then we'll finish this problem. 7, 6. We would write h of 7 equals 6. 8, 7. We would write h of 8 equals 7. Get the idea? Okay, now we're ready to solve this final problem. We're asked to find h inverse of 0. Well, we don't have h inverse as a function. They only gave us the function h. So the first thing we need to do is to create our inverse function. But this is actually very, very easy. Going from a function to its inverse involves swapping all of the inputs and outputs. So the ordered pairs simply swap coordinates. So instead of 0, negative 1, we have negative 1, 0. Instead of 2, negative 3, we have negative 3, 2. Instead of 5, 0, 0, 5, 7, 6 becomes 6, 7, 8, 7 becomes 7, 8. Now, if we want to find the relationship written in function notation, we just use the same skill we practiced a moment ago. We just have to remember that the function name is changed. So h inverse of negative 1 equals 0. H inverse of negative 3 equals 2. This gives us everything we need to solve the problem we're asked to solve. What's h inverse of 0? We can see that right here. H inverse of 0 equals 5. 5 is our final answer for this final part of this problem.